In this video we're going to discover how river gradient and discharge change as you move downstream, and we're going to come back to our old friend the Annalong River to find out exactly how that happens. So the Annalong River is a great little river for us to do this. It's a relatively short little river, but it rises up in the heart of the Mourne Mountains in southeast of Northern Ireland, flows down through the mountains and out here onto a kind of coastal floodplain before it enters the sea. So you can even get a bit of an overview here as the river comes down in an increasing sinuosity and meanders as it makes its way towards the sea. So it makes for a great location for us to come and explore what's going on. But let's head up towards the source of the Annalong River itself. Now we have the watershed marked on here, which means that any of the rain that falls down here on top of this is Slieve Commodore, and over here is Slieve Donard there. So any of the rain that falls on top of Commodore is going to run down this little bit of a slope here towards here. These are the castles of Commodore, and it's a really good place for us to go and kind of explore what happens as the river water, or the water, comes down here. It kind of gathers together first of all, and eventually there's so much water gathered together that it can form these little gullies or beginnings of the river channel, and you can see them coming down here through this. It's very dramatic scenery here. This is called the Castles of Commodore, these rocky outcrops here, and it's quite handy because of the direction of the sun. You can see here the little gullies that are formed. Now, what would you say about the gradient of the river at this stage? It's very, very steep, isn't it? It's very steep because these rivers have their sources very often in upland areas, and upland areas very often are steep. So there's no surprise here that the river channel and the valleys are very steep. You're also getting this vertical erosion. You can see these gullies being eroded through here. This is a path called the Brandy Path. It's an old ancient smuggler's route through the heart of the mountains. It goes all the way over there towards Hare's Gap if you've ever been there. But as you walk across here, you can see some of the things that have been eroded down. You can see the channel beginning to flow down here and gathering together to form the river. So if we come down here just a little bit, we can see just how steep that is towards the start. The river rises, or the source of the river is in that steep upland area. You've got very steep sides, and the vertical erosion begins then to help make that have a very steep gradient as well. However, if we move back down the valley a little bit here, let's get out of this rock. If we move back down the valley a little bit, we can see that already what's beginning to happen here is that the valley is becoming a lot less steep. It's very, very steep there. It's a lot less steep here. Now there is still something of a gradient there, undoubtedly. You look down the side there, look up the side there. This is not the floodplain by any stretch of the imagination, even though you're starting to get some meanders forming there, causing a little bit of lateral erosion pushing it back. But you're now coming out of the mountains and it's a lot less steep, and you're starting to get lateral erosion occurring as well, making it less steep as a whole. So there's the steepness near the source. When we come down, it's starting to get less steep. So we come down here next to Annalong Wood, and we can see here again there's definitely a gradient. I mean, there's definitely a slope there. This is again still not the floodplain, even though the river is meandering a little bit more. But you can see here how much more gentle this is compared to the steepness in towards the source. So you're getting some of that lateral erosion pushing it away, but the river is now coming out of the mountains a little bit here too. And down we come even further. If you've ever walked up towards Blue Lock or Slieve Binion, this is the route that you will have taken up past the river and the Annalong Wood. Now again, you can see that there's a slope there. This is still not into the floodplain, but as we come out of the mountains themselves and onto the coastal strip, we're seeing here that it gets much, much flatter. Let's zoom around a wee bit and get a feel for that. The gradient is much, much reduced here. In fact, if we zoom in to this point here, and if I were to zoom around there, this looks like a very, very flat location. We're now definitely out into the floodplain where the river is able to erode laterally here, and this little coastal area is well away from the mountains. Spring around there and you'll see the source and the steepness up there, but down here in the floodplain it's a lot more gentle. Now this part of the river is quite handy because you can see here that as the river is meandering around, you're getting that lateral erosion, and you actually can see a little bit of a bluff line there. You can see just a little bit of the edge of that bit of the floodplain where the river has been eroding backwards whenever the meander used to be at that point. So we're going to see in this video why whenever the river starts to meander more, it actually also influences the gradient. But let's start off with a river close to the source. As we've just seen, close to the source, it tends to be steeper anyway, and the water, whenever it comes down, tends to come down in a less sinuous manner. So you're going from height A to height B over this distance. So let's draw a little graph that'll reflect that. There's distance along the bottom, there's height A down to height B over that distance, and the gradient is quite steep. Now let's take a look at something that's a little bit further down and onto the floodplain. Well, first of all, the contours are going to be further apart. It's going to be less steep to begin with. But the river tends not to take the direct route. It doesn't do that. It tends instead to do this. Now, what's the graph going to look like to go from height A to height B in this case? Well, first of all, in this case A and B, it's less of a height change than it was here. But also here, look at that distance, relatively short, straight direct distance. This is taking the meandering route, taking the scenic route. If you're ever out walking a dog off a leash, this is the route that you take. This is the route that your dog takes, and your dog ends up walking an awful lot further than you, even though in theory you cover the same distance. So that distance is much, much longer. The time it'll take you to get around there is much greater than there. Whee! Whee! So that means that if I draw on a line here that shows you the gradient, the distance is much, 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 much longer. Therefore, the gradient is much, much, much lower. The direct route gives you the steep gradient. The more meandering, sinuous, longer route gives you the more gentle gradient. So the reason why the gradient decreases as you move downstream is partly to do with the steepness of the slope, the number of contour lines. But it's also partly to do with how sinuous the river is. And rivers closer to the mouth tend to be a lot more sinuous than rivers closer to the source. If we come back into the Analong River, we'll see that in operation. So let's zoom back into the source again. A very straight river and very, very steep slope. The contour lines would be very close together and a very, very direct route. Let's compare that with down here towards this meandering loop, where we have not only are the contour lines here much, much further apart because it's much more gentle. Look at the scenic route that this is taking, and you see that very much in contrast to up here near the source. Steep ground, direct route, gentle ground, scenic route. Okay, and the other thing that we want to quickly look at is why the river discharge increases as you move downstream. Now, discharge is the amount of water in the river, or more formally, it's the volume of water flowing past a point in the river per second. So volume per second is meters cubed per second. Now, why does the discharge increase as you move downstream? To help us with that, I'm going to turn on another layer. I'm sure you're ahead of me. It's a layer for tributaries. So if I turn that on, zoom out a little bit and take a look at what's happening. I'll toggle that on and off. So there's the main channel of the Analong River, but as you move downstream, you get other little tributaries feeding into it. And it's almost like, you know, have you ever been at a party where some people start the conga? They start the conga and everybody else looks on and goes, oh, that looks like the best fun ever. I am so taking part in that. And they come running down. I want to join in. Oh, great. Somebody started a conga. And more people join all the time. And they just join in. And every time they join, they add more water to the river channel. We'll come down here. If you're familiar with this area, if you've ever gone hiking in the Mournes up towards Slieve Binion, up here, you will have probably walked along this route past the Annalong Wood, and at that point this is where these two rivers join, these two main tributaries join together. The path then takes you up across them and you have to go across the river channel. At that point, just a little bit further on up here is where you cross over the river channel. There's that place where you ford over it, but that's part of that main tributary that's feeding in here. So the further downstream you go, the more and more tributaries feed in, more and more people join the conga, so by the time you got to the mouth, the discharge has increased. And that's how the river gradient and discharge change as you move downstream.